So I just wanted to do a walkthrough on this lead code video. So the problem says you're climbing a staircase. It takes n steps to reach the top. Each time you can climb either one of or two steps. How many distinct ways can you climb to the top? So basically it just wants us to find all the possible ways you can climb from the bottom of the staircase to the top of the staircase without repeating a pattern. Okay, so for this, the most immediate solution that I can think of is recursion and using dynamic programming, in which I will use the concept known as memoization. So it's different from memorization, obviously. Memoization helps you to essentially preserve data so you don't have to recompute things that you've already computed. So it saves you from having to do redundant work. So since it's recursion, we have to create something static which won't get redeclared at every recursive call to this function. So I'm going to create a hash map. I'll just call it M, our hash map. And then this is our recursive base case. So if n is less than or equal to 1, you can go ahead and return 1. Okay, and then we can also say if m finds, so we're looking for to see if n has already been inserted in our hash map. So if it is there, then this will catch it. So this will return an iterator at location n. If it doesn't find it, then it's going to be at the same location where end is, and the condition will be false, basically. But if it's true, what we want to do is just simply return n. This is what saves us from having to do extra computation. And we will go ahead and just return this, return m at n. And in here, we're going to do m at n is equal to the recursive calls of climb stairs. So this is where the actual recursion happens. Into n minus 1 plus climb stair at n minus 2. And then once we're done with all of that, at the very end, we're just going to go ahead and return at the final n. So we came up with this general formula, which is just the answer is going to be all the recursive calls at n minus 1 plus the recursive calls at n minus 2. So this is basically going to be the recursive calls. So the formula is this at n, and that is equal to n minus 1 and n minus 2. And I do believe that should already work. I can try it. Yes, and maybe to speed it up a little bit, we can do m dot reserve, and then reserve the restraints. The constraint is 45, so the maximum it's going to be is 45. So we're going to make space for 45 items so that the hashing doesn't slow us down. It probably won't because 45 is a small number for a hash map, but still. And then we can try against many tests, and there we go. And it's pretty fast, as you can see. To make it faster, yeah, you can't make it faster as far as I can tell. But that's basically it for this problem. It was just a recursion problem, and we use memoization to avoid doing extra work. Because let me show you what would happen if we did do all the extra work. Let's see. That should work. I'll just comment these out for now. And we can go ahead and try to run. Okay, let me comment that out. It works, but it's a lot slower. And if we run it with against all these tests that have huge numbers of computations, it probably will take a very long time. Yeah, it says time limit exceeded. And it exceeded most likely because it has a huge input. Um, it does the same exact thing, but it's just a lot slower. And there we go. And that was it for this quick just setup of this problem. Again, thank you.